This is Tech Math 2. And we're going to do section 1-12 and 1-13 in the next 5 minutes and then leave early and eat our donuts. No? Okay, well, yeah, we're going to do that today. That's what we're doing. Whatever. Something's wrong in the front row. I don't know what it is. All right, so section 12, we take real-life formulas and we solve for things. So that's the plan. So we will go and do the ones assigned and do all the ones that are electronics just for the heck of it. Now we did number 2 yesterday. Do I need to do it again? I guess so. Okay, so number 2, the circumference is pi times the diameter. We also know that the circumference is 2 pi, the radius, right? But that's not the equation we have. We have pi with the diameter. And we want to find the diameter, which will be c over pi. When I cross multiply, the pi goes underneath. I got 3, 5, 8 centimeters, which means I have 3 significant digits, and my answer should have 3 significant digits, and my answer should also have centimeters in it. Calculator's on. 3, 5, 8 divided by pi, and I've got 114 centimeters, and life is fine. Except I didn't put a 2 there. Yeah, that's better. Is that better? I got a 2 there. I move down and volume, pressure, volume, area. Oh, we're going to do number 9. Okay, we're going to do number 9. And number 9 says that I'm at 55 degrees centigrade, and I want to convert to Fahrenheit. So I take my calculator, I put in a 55, I go second function convert, I come down to temperature, and I want to go centigrade to Fahrenheit, so I do that, and I push the button, and it tells me it's 131 degrees Fahrenheit. Okay, I'm going to do that again. I put in the number, I go second function convert, and the convert key is the 8. The 8 key is the convert key. The 8. There's blue writing above the 8 that says convert.
Oh, I got it.
Yeah,
Got it.
exactly. And then I move to temperature. If I could spell temperature. I move to temperature, and then I go degrees centigrade to degrees Fahrenheit, and then I hit enter, and I get the right number. Now, why are we doing that? Well, because you're going to be doing that forever and ever, and with this calculator, you don't need the equation. Why worry about it? Now, the reason that we're doing it is that if it were minus 55, and I wanted to go degrees centigrade to Fahrenheit, and I put in minus 55, second function convert, temperature, centigrade to Fahrenheit, it would tell me that I'm minus 131 degrees Fahrenheit, which would be wrong. What I have to do to make the calculator do the right thing, what the calculator just did is it took 55 degrees, changed it to Fahrenheit, and put a negative sign in front of it. Oh, thank you, calculator. Paid 20 bucks and you're going to do that? Yeah. But if I put a parentheses, 55, and do the same thing, degrees centigrade to Fahrenheit, I'm going to get the right answer. So if I put in parentheses, minus 55, close parentheses, second function convert, temperature, degrees centigrade to Fahrenheit, and I get minus 67 degrees, that is correct. See the difference? So it's an order of operation thing. The computer is doing an order of operation. It's doing the 55 to Fahrenheit first, adding the negative sign second. Not what I would have built the calculator to do. Okay, so now that we've done that both ways, we'll now solve the problem the way we're supposed to in chapter 1. All right, so I got number 9. But I don't expect you ever in your entire life to use this formula because you have the calculator that does the conversion. So you should use that. All right, so I've got 55 is equal to 5 over 9 f minus 32. I invert and multiply times 55 f minus 32. 99 is equal to f minus 32. And I get f is what? 141. Is it supposed to be 141? 131. How come I got 141? Because I can't add? Yeah, 131. Okay, there we go. Yeah, 99 plus 32, 1 to carry, 131. Okay, so that adds it. But the issue is, when you're using your calculator to go Fahrenheit to centigrade or Fahrenheit to Kelvin or Rankine or whatever you're going to, if it's negative, put it inside parentheses. That's the bottom. Okay, so then we have a length. Well, we have to do 11. Okay, so number 11, I have some heat transfer. So I have some amount of heat, Q, is the mass times the heat capacity times the change in temperature. Okay, so the mass is 500 grams, the 3 significant digits, and C is 0.241 calories per gram, and delta T is degrees centigrade. Delta T is 40 degrees centigrade. All right, so I look at that and I see that grams go away. Get a different color. Grams are going away. Degrees centigrade is going away. And the only thing I have left is calories, which is perfectly okay to have. And I have 3 significant digits because this is 500 with a line and this is 0.0 sitting there. So I have 3 significant digits everywhere. 500 times 0.241 times 40. And I have 4.82 kilocalories. Okay, now I could have written that as 4820 calories. I could have written that either way. So either one of those answers would be perfectly okay. We sort of like to have kilocalories because calories are so small we don't really care about them. We just, how many calories are there in the donut? Not very many, right? That's why we can have a couple. No? Whatever.
0, because that's what it should
0. That's, yeah, all the calories were in the middle and they took them out. That's why it's a donut. Yeah, you didn't know that? Uh-oh. Rajanae's shaking her head. That must mean I'm out of line again. Okay, so I guess we need to do 13 next. All right, so we'll do 13 next because it's an electronics problem. So X, the inductive capacitance is 2 pi FL. All right, so I got a 2, and I want to find L. All right, so I'm going to solve for L. L is going to be X of C over 2 pi F. All right, so I got 70 F of L. That's an L. 75. 75.0 ohms divided by 2 pi 60 hertz. I have 3 significant digits. When I get done, my answer is going to be in Henry. But you could leave the answer in ohms per hertz if you didn't know the answer was in Henry. So you don't. Anyway, back to 75 divided by 2 divided by pi divided by 60. So to three significant digits, I have 199. If I had my marker, there it is, 199 Henry. But there's nothing wrong with having 199 ohms per hertz. There's no technical reason that isn't right. Except that ohms per hertz would be multiple digits in Henry. Well, Henry is multiple digits too, or multiple syllables, right? Henry, something like that. That was 13. That was 11. 13's next. We'll do 14 next. 14. So the current, let's see, V is equal to IR, so that we know that. So current is going to be V divided by R. And in this particular case, we're using E for the V, and we're using the resistance of the load plus some little r. So this would be a case where you had a transistor, and little r is sitting up here, and I've got some load resistor sitting out there, and I'm adding them together. Okay, we don't care about that. What we care about is we have to solve for E. So E is for electromotive force, also known as voltage. Only the English would change voltage to E, right? Yeah, they would, because voltage is from Italy, and if I'm from England and I'm in London, I can't use voltage. Voltaire was part of the thing that cut off heads with a guillotine type guy. So we have to go and use E. Okay, so we're going to use E. Thank you very much. I, RL plus R. So yeah, it's really cool how much of what we do is that way because of history. So I got 2 amps, but I have it to 2 significant digits, and I have resistance of 28.0 ohms and a half ohm. And I have 3 significant digits everywhere. So what is 2 times 28.5? 56, 57, 57 volts. Really? 28.5 times 2. Oh, lucky guess. No, it wasn't a lucky. Yeah, it wasn't a lucky guess. Okay, we'll go with lucky guess. Would it be okay to leave it 57 amp ohms? Well, it'd be weird, right? But it'd be okay. If the units aren't wrong, they can just be simplified. Power, yeah, well, we care about power, but not in tons. Number 16, we did the other day, so we won't do that. 17, we'll do 17. 17 is dangerous to do, though, right? Because I have to get it right. It's in the back of the book. So the primary number of primary. Oh, this is pressure and temperature. Now we're not doing 17. This is a physics problem. So we won't do that. But we will do 18. X sub c is 1 over 2 pi fc. So the reactive capacitance is 1 over 2 pi c, and we want to solve for frequency. So frequency is going to be 1 over 2 pi x sub c c. 1 over 2 pi 1,000, 1 k ohms, and who did that? 2.65 times 10 to the minus 6. Is that possible? Can I find a capacitor that's 2.65 times 10 to the minus 6 farads? Well, yeah, I could, but I can't buy it. So it's going to be 0.1 farad or 0.10 farads or 0.001 microfarads or something. So obviously a made-up problem. But we can come up with what frequency on that, so that's all we really care about. 1 divided by, parentheses, 2 times pi times 1,000 times 2.65 double E minus 6, close parentheses, and if I did it right, I'm going to have 60 hertz. And so I'm going to round it, yeah. Am I going to round it to 60.1 hertz? I might. I might round it to 60.1 hertz, or I might keep it at 60.0 hertz. It's either one of those guys would be perfectly okay. Is 60 hertz correct? And the answer is no. 60 hertz not correct. Minus 0.1 significant digits. Okay, so 60 hertz wouldn't be correct because I have 3 significant digits. I should keep them. But it's not incorrect to the point where it's minus 1. It's only incorrect to the point where it's minus 0.1. So it's not totally wrong. It's just sort of like in Princess Bride. You know, he's not totally dead. It's only a little bit. You know. Well, mostly, right? Not a little bit.
No, I haven't seen it.
Okay. Well, we don't care about force in 20. And force again, and velocity not. No, I don't care about those things. Okay, number 27 is the next electronics problem. And we'll try to change colors here. So 1 over R is 1 over R1 plus 1 over R2. Now we normally write this as R total. The author didn't do that, so we didn't do this, but we still want to. Anyway, so we want R1. Okay, so 1 over R1 is going to be 1 over R total minus 1 over R2. And then we can flip those guys and say R1 is equal to 1 over R total minus 1 over R2. And now it's time to put it in our calculator. 1 divided by parentheses. I'm going to put 1 divided by open parentheses. 1 divided by R total. We're probably working anyway. 27. Okay. So it'd be 60. One divided by 60 minus 1 divided by 240, close parentheses, and we get, so I guess I better do this, 1 divided by 60 plus 1 divided by 240, close parentheses, and it gave me the answer of 80 ohms. 80 ohms. So this is resistance in parallel. So I got one resistor 80, one resistor 240. The total resistance has to be less than the smallest guy. That's the idiot check we do, less than the smallest guy. So it told us it was 60. We got an answer that was 80. We're perfectly happy with that. Do we need to check our work? Probably not. Okay. Say again?
I said mine agrees.
Your calculator agrees with 80? All right, now, we use Z for impedance as well. So instead of using R, we use a Z, is 1 over Z1 plus 1 over Z2 plus 1 over Z3. And we use a Z for impedance, which means resistance, in an AC circuit. So it's just a vocabulary thing. Resistance is a DC thing. Impedance is an AC thing. They're the same, but they are different. All right. And this guy here says that we'll comment on how hosed the problem is later. We want to find Z total. Okay, so Z is going to be 1 over Z1 plus 1 over Z2 plus 1 over Z3. So we put that on our calculator. 1, open parentheses, 1 divided by 25 plus 1 divided by 15 plus 1 divided by 50, close parentheses, enter. Now, we know that our answer has to be smaller than the smallest one, right? So the smallest one is 15. Our answer better come up as less than 15. Oh, bummer. I didn't enter it right. I'm not gonna tell you how hosed I am because it's really bad. But if I go 1 divided by my answer, I forgot to put a divide sign in. 7.89. 7.89. Is that what you got? Bummer. It's got to be less than 15. So that means I have to enter it in my calculator again. 1 divided by parentheses 1 divided by 25 plus 1 divided by 15 plus 1 divided by 50, close parentheses. Yep, got the same thing, 7.89 ohms. Now that we've done that, on a scale of 1 to 10, where 1 is the least acceptable ever, and 10 is there's no problem with this at all, where does this problem lie on that scale? Right up here. Totally unacceptable. Why is the problem totally unacceptable? Because our impedance didn't tell us what angle it was at. It was treating the impedance the same way as we treat resistance. But the impedance, if I have some x of L, it's that way. If I have some x of C, it's that way. So my impedance is some number that's a magnitude and an angle. So impedance 1 is some magnitude and angle. Impedance 2 is some magnitude and angle. Impedance 3 is some magnitude and angle. If my angle is 0, don't call it impedance because now it's resistance. Okay? Oh, perfect. That's great. I just made a basket with the marker.
Did you intend to skip 3 and 31?
Did I do that? I did. I'll go back and do 3 and 31.
What was your answer?
7.89 right there.
Yeah, I entered it wrong the first time.
Okay, excellent. So you have to do what the problem says, but the problem shouldn't have been written that way. Yeah, I did 2 instead of 3. How come I did that? All right, back to number 3. Area is 1/2 the base times the height. So this is a triangle, right? It's a right triangle, so area is 1/2 the base, or it doesn't have to be a right triangle, it can look like that. So 1/2 the base times the height. And we want to find the height. So the height is going to be area times 2 divided by the base. 2 times the area, 144 inches squared, divided by 8. Oh, it's in meters. 8.00 meters squared. We'll change the top guy to meters. All right, well, let's see. 2 goes into 8, giving me a 4. 4 goes into their 36 times, 36 meters. And one of these isn't squared. Which one isn't squared? The 8, the height isn't squared. All right, that's good. And we say, well, do I believe that 2 times 144 divided by 8 equals 36? Okay, lucky guess, Corville. And we'll move on to 31. Now 31 is a problem dealing with lenses. So the focal length, F is the focal length, S0 is the height of the object, SI is the height of the image. Why they didn't use H, I don't know, for height, but they didn't. But in physics, S is commonly used for distance. All right, so back to what we're doing. And is there any difference between this and finding total resistance in a parallel circuit? Absolutely not. Same exact formula, just different things. Okay, so we want to find the we want to find the height of the image. So the height of the image, 1 over F minus 1 over height of the object. All right, so I put that on my calculator, 1 divided by, close parentheses, 1 divided by 15 plus 1 divided by 20, close parentheses, and it says that I'm at, the focal length is the height of the image, 8.57 centimeters. And what did I do wrong? We know that that answer is wrong, right? Because the same rules that apply to resistance has to apply to this. This answer has to be bigger than the focal length, which is 15. So I look at my calculator and I say, oh, bummer, I added when I was supposed to subtract. So I didn't subtract here. So I'll go back up and see if it lets me do it again. And yes, it does. Okay, so I'm going to put a negative sign where the positive guy is. Okay, now we're better. So this guy's wrong. 60.0 centimeters. And then we look at it again and we say 60 and 20 giving me a 15. 15 is less than the other two. Idiot check passes. Okay, good enough? We're now in section 1-13, and what do? We do the same thing over again, except this time they give us words. All right, so we look at, so we have to make, instead of having the equation because they give it to us, they give us words and we have to make our own. A set of 8 light bulbs, no, it doesn't say light bulbs, a set of 8 built-in bookshelves is to be constructed in a room from the floor to the ceiling. Clearance of 9 feet, 9 feet, 6 inches. The shelf are 3/4 inches thick and are equally spaced, and spacing is desired between the shelves. What is the space between the shelves? Assuming there is no shelf against the ceiling and no shelf against the floor. Okay, so we draw ourselves a picture. Got 9 feet, 6 inches from there to there. And I've got 1, 2, 3, 4, 5, 6, 7, 8 shelves. Each of them is taking up 3/4 of an inch. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So I have 9 spaces, 8 shelves. All right, so I'm going to take my 9 feet, 6 inches, and I'm going to divide it by 9. I'm going to subtract. I'm going to subtract 8 times 3/4 for the wood of the shelf, and then divide it by 9. All right, well, we have apples and oranges, so that's not going to work. So I got 9 feet, so 9 times 12 is 108, plus 6 is 114. So I got 114 inches minus 4 goes into there twice, times 3, 6 inches, divided by 9 spaces. 108 divided by 9. 9 goes into there. 12 inches. 12 inches. So now we ask ourselves significant digits. Gee, we only have one significant digit. What are we going to do? Call it 10? 10 inches? Or call it 1 foot? I think we should call it 1 foot. What do you think? Yeah, I think so too. All right. So I am wearing long sleeve shirts, so is there anything up my sleeve on that one? Okay. But with word problems, the better the picture, the closer to the right answer you'll become. You ignore the picture, and chances are you're going to be on the other side of the correct answer. Number 7. 40 acres of land. So I got 40 acres, and I paid $20,400. That's pretty cheap, isn't it? That's pretty cheap. The land facing the highway. So I got some land at $650. That's highway per acre. The remainder was $450 per acre. How much land did I purchase for each price? Okay, so I know that 20,400 is equal to 650 times the highway plus whatever the highway number of acres was, plus 450 times the other. And those aren't variables we like, right? So we'll just call it A and B. A, B. This guy's A. That guy's B. And we also know that A plus B is 40. All right, so now I look at that and I say, well, I have 2 equations, 2 unknowns. 650x plus 450y is equal to 2400, and x plus y is equal to 40. Why don't I change the variables to x, y for anyway? Weren't a's and b's perfectly okay? Well, because I'm going to use my calculator. That's right. So you see on the calculator the tangent button. And you see in blue above the tangent button it says System Solver. Second function, System Solver. And I have 2 equations, 2 unknowns. Boom. And my x is 650. Enter. And I want a plus sign. And my y is 450. And I have 2400. 2 by 2. 2 equations, 2 unknowns. 2 by 2. If I had 3 equations, 3 unknowns, I'd use the 3 by 3. So number 1. Yeah. And then I come back to here and I have 1x, and I put in a plus sign, and I have 1y, and I come up with 40, and I hit the solve button, and it says that my x is equal to 12, and my y is equal to 28. So I have my final answer, 12 acres, or highway acres, and 28 acres are not highway. Now I could have done that differently, right? Want me to do it? Want me to do it differently for you? All right, we'll do it differently. So I'm not going to use my calculator. I'm going to use some other method. Copy. Edit. Paste. Okay, I'm going to use Cramer's rule. I'm going to use Gaussian reduction. All right, we'll vote. How many wants me to use Gaussian reduction? All right, how many want me to use Cramer's rule? How many wants me to go to the next problem because we already have the answer? All right, so Cramer's rule says that if I have something that's ax plus by is equal to c, and dx plus ey is equal to f, then x is going to equal the determinant cf be divided by the determinant a, b, c, a, b, d, e, and y is going to equal a, d, c, f, determinant divided by a, b, e, d, e, determinant. All right. I'm glad I covered that, right? So translated into English, the guy on the bottom, which we're going to use twice, A, B, D, E. So we're going to use that guy twice. This is going to be, I'm going to multiply that way, A, E, and I'm going to subtract, multiplying that way, D, B. That's what I'm going to do. All right, so I come back and I say 1 times 650 minus 1 times 450, and I'm going to get the awesome 200. Okay, so now I have 200 that's going to go in the denominator of both the x and the y guy. All right, so now x is equal to, on the bottom I got 200 because I already did it. On the top I have 20, 40, 400. I got a 40 there. So that's my C and my F, those guys there. And then I need a 450 and a 1. 450 and a 1. Okay, so I'm going to have 2400 minus 40 times 450. So 40 times 450. And I have 18,000 on top, divided by 200. The zeros go away, and I took away too many zeros. 402 minus 180 equals, divided by 2 equals 12. And now that I know that it's 12, I put it back here, and if it's 12, then y has to be 28. I don't do it on the other side. So y is 28. Okay, so how many people recognize that as something that they did in their high school math class? Okay, yeah, totally wonderful. Now, wouldn't it have been greater to have a calculator like this that just did it? Yeah. So there's 5 different ways to solve 2 equations, 2 unknowns. We cover all 5 of them. But when you come across that equation, I expect it to go in your calculator and you give me the right answer. But we will cover all 5 ways because we're that type of guy, you know. I like the Gaussian reduction. I don't believe no one wanted Gaussian reduction. I mean, you want a Gaussian reduction, right? No, no one wanted a Gaussian reduction. That's my favorite way. Number 20. A test solution of gasohol contains 60 liters of gasoline, 40 liters of alcohol. How much pure alcohol must be added so that the resulting solution is 25% alcohol? Okay, so I solve these problems the same way every time. I make a picture. So I've got something, and I'm adding something to it, and I end up with something. All right. So I have 60 liters of gasoline and 15 liters of alcohol. How much pure alcohol must be added? All right, so over here I've got 60 liters of gas, and I've got 15 liters of alcohol. Okay, so I've got a total of 75 liters, and what percentage of it is alcohol? So 15 divided by 75, I'm at 20%. So this is a 20% solution of alcohol, and I'm adding to it pure alcohol. So I got 100% pure alcohol. I don't know how much I'm adding, though. It's X. And when I get done, I get 25% of 75 liters plus X. Okay, so I'm gonna go across and say 20% of the 75 liters plus X of the 100% guy is equal to 25% of the 75 plus X guy. Okay, so I'm going to change the percentage and call it 0.2 times 75 is equal to X. No, it's not. Plus X is equal to 0.25 75 point plus X. Alright, so 0.2 times 75. 15. So I got 15 plus X is equal to 75 times 0.25, 18.75 plus 1/4 X. Okay, so 1/4 X goes on the other side, and I've got 3/4 X is equal to, the 15 goes on the other side, 3.75. X is equal to 4/3 times 3.75. 4/3 times 3.75. 5 liters. So if I add 5 liters of pure ethanol to 75 liters of 20% ethanol, I end up with 80 liters of 25% ethanol. We'll check our work.
Did you go down?
Before I check my work.
When you got to, I followed you all the way to the 15 plus X.
See that line there? Do you follow that line there?
I don't get where did the 3/4 cents come from?
You know, the one.
Oh, this 1/4 goes to the other side as a minus 1/4.
Oh, okay.
Yeah, so that one over there. Now, when you got to this equation right here, there's no reason you can't just enter it in your calculator and have it tell you what the answer is. Okay, so I'm going to go second function, numeric solve, clear both sides of my equation from the junk I had it yesterday, and I'm going to go 0.2 times 75 plus X equals 0.25 times parentheses 75 plus X close parentheses, enter, solve. It tells me my X is 5. So at this point, when I get to that point of setting up, my calculator will tell me the right answer. I don't necessarily have to go past that point. And we could quit here, or we could do number 24 before the rest of your classmates show up. One of 3 angles is 5 degrees more than the smallest. The third one is 3 times the middle. The sum of the angles are 120. Okay, so we have A plus B plus C is 120. That's the first one. One of the 3 angles is 3 degrees more than the smallest. 5 degrees more than the smallest. So A plus 5 is going to be B. He's the guy in the middle. The third angle is 3 times the middle guy. So C is going to be 3 times B. Okay, so I got those equations. I'm going to rewrite them. I'm going to rewrite them X plus Y plus Z equals 120. X minus Y is minus 5. And minus 3Y plus C is 0. So I have 3 equations, 3 unknowns. There's multiple ways we can solve that, but we already saw that our calculator does 3 equations, 3 unknowns, so that's what we're going to do. Second function, system of equations, and this is a 3 by 3 guy, so we move down to the 2 position. We put in a 1, a 1, a 1, and a 120. We put in a 1, a minus 1, not a negative 1, but a minus 1 with the minus key, a 0 for the z guy, and a minus 5, not the negative 5, but the minus key. We put in a 0, a minus 3, a 1, and a 0, and we call this z, of course. And then we hit solve, and it says x is 20, and y is 25. I could have predicted that, 5 times more than the littlest one, right? And the last guy is 75. Z is 75. And now we have the right answer. Now we could have gone and done it manually, right? I could have substituted in, I could have done Gaussian reduction, I could have used Cramer's rule. Could have done any of those things. But I didn't. I just grabbed my calculator, I had 3 equations, 3 unknowns. Now that I have the equations, I just put it in my calculator, poof, the answer's there. Okay, thank you very much. And who is missing?